Okay, so diving into number 2, most of you had thought through and set up your diagram at this point, or if not all of you guys, correctly. And at first a lot of us, maybe we thought, well, if halfway was 22, then wouldn't he just land at 44? But eventually when you guys discussed it, you realized that because we started at a height of 2, once you go another 22, that's going to be at a height of 2 again. There's a little bit more to go here before it actually hits the ground, right? So it would be this point where we're at 44, right? So this is going to involve more than just purely utilizing the symmetry of the parabola. We're going to actually have to figure it out another way. But luckily, we know that the path of something flying through the air is parabolic, meaning we can use a quadratic. And also, luckily, we are given information. In fact, we are given the vertex. 22, 13 is the highest point, right? So it's probably fairly easy to see here that we know y equals a times x minus 22 squared plus 13 is going to be the setup for a formula or a function to represent this path. The only problem right now is we don't know this a value, so we're going to have to do a little bit of work right now. The good thing is we know some other coordinates on this, right? We know that 0, 2, if you want you could use 44 too. So go ahead and check your own work. I'm going to plug that in. I'm going to pause it and then do the work myself, figure out what a is. So if you need to pause just to check your work, like this isn't something you were very fluent on, go ahead and pause it. But essentially I plugged in 0, 2 from this coordinate pair here for x and y, and then I solved it for a. One thing to remember when solving this is I subtracted 13. I used backtracking. And then this I just calculated, negative 22 squared. And then we just divide and we simplify it, so we get our a value. Now let's put that back in and we can finish solving. So our actual complete function that matches this is negative 1 over 44 times this, plus 13, right? And we would expect it to be negative because we know that makes it the parabola facing upside down. And we would expect something like 1 over 44 because if you remember, that small of a number close to 0 means it's going to be a really wide parabola, which again, that makes sense in a situation like this if something's being shot through a cannon, for example, right? But the question becomes, if I'm really trying to search out where Barney hits the ground, what coordinate is helpful there? Well, hitting the ground goes with when your height equals 0, right? The ground is at a y value of 0. So really what we're trying to do here then at this point is figure out if y equals 0, what is the x value? Because we don't know what that x coordinate is going to be, but we do know that we want the x coordinate that happens when y equals 0. So we can just plug 0 in for y and then solve this equation for x, and again we're going to use backtracking to do this. Okay? So I'm going to write all the steps out and come back together to finish it off. Okay, so to finish this off, okay, we're solving for x, right? So subtracting 13 must be first from both sides. And then this negative 1 over 44, I multiplied 44, negative 44 on both sides. This will cancel out, and then that becomes positive 572. And then I need to square root on both sides. So I get x minus 22 equals square root of 572, and then I just add 22 over there. And that ends up being about 45.92 meters. A lot of you had guessed that it's maybe about 46 meters or so, and that was great. So here's the exact value for where he lands, and another cool application for quadratics.